Just started.
Just started. Cool. Okay. All right. How much time does it take to run your complete automation suite?
1.5 hours.
Okay. Same.
No, not even started.
Oh, okay. Okay. Cool. So I think that gives me a good start. Alright. So welcome everyone. My name is Rajdeep Varma. I'm a QA here at ThoughtWorks with total 5 years of experience in quality engineering. I'm passionate about test automation, continuous integration practices, and getting value out of it in an agile environment. In ThoughtWorks, I've tested a lot of web application in my past, and I recently started working on a mobile project, and we are building a suite of mobile application for one of the world's leading airline company. So when I started working for mobile project, I obviously started, so shifting from web to mobile, definitely there was a complete mindset shift, and I started facing some issues specifically related to mobile testing. And today I am going to talk about two of them. One is long running automation. Second is running automation on multiple devices. So long running automation is basically if you have continuous integration pipelines setup already done, and your test automation is taking a lot of time. So how to solve that problem? And to solve that problem, I created an open source tool called Parallel Calabash. Many of the users of this tool, they have used it because they had to run their automation suite overnight. It used to take 6-7 hours. That was a huge amount of time, and definitely one cannot run those tests on every check-in. So that's the first part of the problem. Let's start with it, long running automation. So as you see, this is a typical CI pipeline of a project. So your developer or whoever is developing, they change the code, do a git push or whichever source control tool you guys use. Then the code gets compiled and unit tested, and you build the application, and then that application is passed through a safety net of UI tests. And if everything is green, you can distribute the application to your users or to your testers using build distribution systems like Hockey app or test player or whatever you like. The whole point of running your test on every check-in. So you see git push is triggering UI test. The whole point of it is to get the fast feedback. And that's why slow running tests are a pain. So many people say 6 hours is fine with us, we run it overnight. That's okay, but if you want to run it on every check-in fast because you want to get fast feedback, it's really important to run your test on every change. You can track down which is a bad commit, and you can filter out the things then and there itself. This is a very simple linear pipeline, but this is somehow how our current pipeline systems look like. So on the top right-hand corner, the blue highlighted part is what our entire dry automation regression suite is. On left-hand side, you see there are 5 green highlighted box, and those are Git repositories. And any check-in in any of the Git repositories is going to trigger the dry automation. The reason why 5 repositories, one is the Android source code. Second is a common source code which is being shared across all the platforms like Android, iOS, mobile web, or many other platforms which we are building our apps for. Third Git repository is for middleware layer, service layer. So if there is any change in the service layer, we want to test whether it's compatible with our current application. And another one is the automation repository itself. So any check-in will trigger the dry automation in any of the 5 repositories. And here are some stats. 5 Git repositories, we have averaged 30 commits a day, and we have approximately 100 UI tests, out of which currently we are running somewhere around 80 or something. But total we have 100 tests, and our time from a git push to get a tested OK build is more than 1 hour. And see what happens with slow tests. So a developer is developing something, does git push, and everything got compiled, unit tested, and your UI test starts running. And these are slow tests. You go for a chai break. You come back and see, oh, test failed. Never mind, you know what the fix is. You fixed it. And again, the UI test started running. And these tests are really slow. 1 hour, right? You already had spent 1 hour, and this is another 1 hour you're going to spend. This time you pray.
Should pass.
They should pass. Yeah. So patience is not always a virtue. Sometimes waiting unnecessarily does not make any sense. Now you have to choose one, either lots of automated tests so that you can give a good coverage, or you can have few tests like a smoke pipeline, which will just run 3-4 tests, will get finished up in 10-15 minutes, and you are happy. But you have to choose any one of them. How many of you will choose A? No one. Can I say others? How many of you will choose B? Some people did not raise. What will they choose?
No, you want us.
That's good. So we chose both. Okay. Now, obvious question is how. So modern machines have multiple cores, and we can utilize our build agents, CI agents, to their optimum capacity. So generally we have machines like i7, or let's say 4 core, 12 core machines or whatever. We can use those cores to parallelize the tests. So we were building mobile web, Android and iOS. I'm not going to talk about iOS, but so for mobile web we were using Cucumber, Water WebDriver, and this fantastic tool called Parallel Test for doing parallelization of the Selenium test, the Water WebDriver test. But this did not have any out-of-the-box support for mobile, and that's where when we were doing our Android testing using Calabash, we thought of creating our own tool, Parallel Calabash. So, but before that, let's see what options we had thought of for parallelization. So one was multiple parallel builds in CI. So you have a huge automation suite. You can create 4 builds out of it, and you can run all those builds in parallel. But if you want to run 4 builds parallel, you definitely need 4 machines, right? It's a cost associated with hardware, and it's not scalable. Let's say today you have 50 tests, tomorrow you keep writing automation, you have 100 tests. So can you keep adding more and more agents? As in, it's not a very scalable solution. Another was proprietary cloud-based tools. So there are service providers like pCloudy, Xamarin Cloud, and many others which can solve this problem for you. But they charge hefty money, like $10,000 per month if you are a business user. We did not have that much money. So a very easy and very simple solution was to create a tool. We know the languages, and we can just use the language features like multi-processing or multi-threading, and we can create a tool that matches exactly what we need. Okay, and that's where this project started. And I'll give a quick demo of what I want to show you with the parallel testing. Okay, can you guys at back see my screen? Okay. So for this demonstration purpose, I have created a simple UI automation test suite, which has okay. So this is a simple suite built with Calabash Android framework and Cucumber, of course. Those who don't know Cucumber, it's a tool wherein you can specify your test in a business readable language, and you can implement those business readable lines into backend Ruby code like this. So this entire test suite has total 8 feature files. 8 features as an so feature files are basically you can write multiple scenarios in one feature file. It is very it's a specific to a business feature. So right now there are 8 feature files. One feature file has like 2 scenarios, and some feature file has 1 scenario. Total 12 scenarios, and the application under test is something like so it's called boot camp, but it's a calculator. So it can add 2 numbers. You can say 4 and 4, and when you say plus, it adds a number and it will give you the result. So as feature files are grouped in number of digits the calculator can add. So it's like single digit addition. Similar way we have double digit additions. So it verifies that the calculator can add 2 digits. And similar way something like 8 digit additions. So my calculator can add 8 digits. So let's see how much time it takes when I. So those who have used Calabash Android, the way we can run our test is Calabash Android run, and then we can specify the APK file, and we need to give our features folder. And the test started. Okay. So 12 scenarios. It will take somewhere around 50 seconds. Let's go for a chat. Anyway, so let's see the CPU utilization here. This point onwards, you see the spikes here, right? For these 4 windows, because this is a 4-core machine, the test started this point onwards. This point, this was the previous thing. So the spikes you see is basically the tests running. Still running. Okay, finished. It took 51.4 seconds. I'll highlight it. Can you see this? Okay. Now let's say I want to reduce this time. 51 seconds is too much for me. So what I have done right now is I have connected multiple simulators to this machine. You can connect multiple devices also. So this is not limited to simulator. So let me. So there are total 6 devices right now. Okay. Okay. So let's run this in parallel. So for this, we have to install this this gem parallel Calabash. It's available in the form of gem this tool. So you can say gem install parallel Calabash simply, and then you'll get an executor called parallel Calabash. So you can say parallel Calabash. There is a switch to specify your APK file -a. Create a screen. You can -a for specifying the APK, right? bootcamp.apk, and then you can specify your feature files. I'll give it one more option to it's called group by scenario, because there were 12 scenarios and I want to distribute each scenario equally on each device. You can distribute by features also. So let's say you want to execute one complete feature on one device, you can do that also. Right now I want to distribute using scenarios. So there is a switch called group by scenarios. And I say enter. And you say it says 6 devices found. Scenarios got divided equally, and each device get 2 scenarios. It's done. And you see the spike in CPU usage here. So earlier, I think this is already gone here. This complete stretch was for series, and the stretch time is reduced, but the usage has increased. It's like shrinking the time domain, but increasing the utilization. You can see like CPU is getting a good access. Yeah. And the total time it took was 20 seconds. Okay. So we are down from 51 seconds to 20 seconds. Okay, let's move back to the slides.
If you ask me,
Sure.
how can you divide? So how do you divide the test and compare this to the
Yeah. I'm sorry. Yeah, so it's the same thing which I was talking about, shrinking the time, increasing the utilization. Here is exactly what how I divided test. So let's say I give it a feature folder. Like I want to run all the tests inside this feature. We can give multiple feature folders by default. So it will just see how many feature files are there in those folders, collect them all, and it will detect how many devices are currently connected. So let's say you have 6 devices connected, or let's say 4 devices connected. It will group all the features into 4 groups. Right now I'm talking about features, not the scenarios. So it will group all the features into 4 groups based on how many devices are connected. Let's say we have got our feature groups ready. Then there is a process spawner module written. Uh, so this tool is written in the Ruby language. And it's very easy to do parallelization stuff like this in Ruby. And so there's a module called process spawner which spawns as many processes as that of number of groups which we have. So we have 4 groups, we will spawn 4 processes. And each process will get its own execution environment. The reason why we why I kept it to parallel processing rather than parallel threading was because I want a unique execution environment for each process. The reason being each process will have its own environment variable. Right? And that's how I set the environment variable in each process. So each process I set the environment variable ADB device R, which will be the device argument of the ADB device argument of the device. So I have 4 devices, 4 processes. Each process will get each device's argument. One more thing which I set is test process number. I'll come to it why we need to do it. So after let's say we have 4 processes started, each group will get passed to each process, and all the process will run parallel. And at the end, we will after the run has completed, we summarize the result and we show it on the standard output, which is terminal in this case. So that's how the division and processing happens. I'll quickly talk about the reporting because it's very important if you have 10 devices connected and you want to know which test ran on which device. So there's one more environment variable called device info set in each process. Let's say you have 2 devices. One is Samsung Galaxy S5 and second is let's say Moto E. So you want to know which test ran on which device. So I set this environment variable called device info. It will know which process has which device. So your report will look like my report underscore GTN 7100. That's or maybe my report underscore Samsung Galaxy Note 2. So each process, each device will generate its own report. So if you have five devices, let's say I ran on the 6 devices right now. I have 6 reports ready to do. So I talked about distributing by features, but that's not very optimistic way. Let's say you have 2 feature files, or let's say you have 4 feature files and 4 devices, right? If you distribute by features, one device will get 1 feature file. But let's say one first feature file has 8 scenarios, and second feature file has only 1 scenario. Basically, one device will just keep waiting for, or maybe it's not optimistic, right? it will just sit idle there. So to distribute the so ideal way would be to distribute based on the scenario. So how I do it is, um, when you run a test, you pass various parameters to the cucumber. In cucumber ops, you can pass the tags or a filter or whatever you want. You have 10 tests, you can pass. I want to run the test marked with @Android. I don't want to run something marked at @WIP. Or we had really fancy names in our automation suite, genuine feather, we don't want to run them. So after filtering out everything, or maybe @manual, it's a very famous tag. So after filtering all these things, let's say we remain only with 10 let's say 15 scenarios, we just have 10 scenarios which are runnable. And I want to divide those 10 scenarios into. So Cucumber by default luckily gives a feature of dry running. And by using dry run, you can create a dry run JSON output. So whatever your users pass to, okay. So whatever arguments are being passed to parallel Calabash, it first does a dry run. After doing a dry run, it creates a JSON report. And that report gives you how many scenarios can actually be run out of after filtering all the things. And based on those, we can group by scenarios. Let's say there are 10 scenarios and 5 devices. You can remove all, like, group the scenarios into group of 2 each and distribute on each. And that's where the group by scenarios tag, this switch was given to parallel collaboration. Some advantages of fast tests: we obviously get fast feedback. Like for our test week itself, it was taking somewhere around 15 minutes or something with all the tests, and we reduced it to something 15 minutes. Faster development cycle for BDD environment. You get fast feedback, you can develop fast. You have good machines, you can utilize the full capacity of it, and faster test makes developers and testers. Let's go back to the so we already talked about one thing, long running automation. The other problem is that specific to mobile automation is running automation on multiple devices. So I have automated 10 tests, but generally we run our automation because our CI agent has some devices connected. We run our automation only on one device. What we want to do is we have already automated something. We want to run it on all the available devices. Let's say for our application, the airline company itself has users with more than hundreds of devices available, and we want to make sure that all the features work on different screen sizes with different manufacturers, different Android operating system. Let's say Jelly Bean, KitKat, or whatnot. So we want to make sure that everything works. All the tests should pass on all different devices. And to do this, again, there was one more feature introduced that was called concurrent. So I have 10 tests, 5 devices. All 10 tests will run on all 5 devices. It's basically multiplication. 10 into 5, you end up running 50 tests. So this was the problem of device fragmentation. You want to test on all devices, and that's how, if you just pass a tag called concurrent, hyphen concurrent, it will run all tests on all devices. The simple thing which I do here is I do not group the features by any. I just pass entire feature block to all the processes. So what did we achieve? So for our project, we achieved 70% increase in testing velocity. Right now, we are running on 8 parallel simulators. Scalability, a very important thing. So let's say we keep writing automation, we love it so much, right? Like few months ago, we had only 50 tests, and suddenly one new feature came into development, and we like almost doubled the test cases, and time also get doubled, obviously. So the simple thing which we did was double the simulator. So If you have 8 simulators, okay, running in parallel, you have more tests, add 2 more, keep adding, keep adding. Reporting, nice reporting, you get which test ran on which, how much you, which device. So this test process number environment variable, I told I'll talk about it later. So there were some issues with some users. One guy using this had this issue that he cannot. So their application has limitation that one user can log in on one device only. So there were no using one credential. We cannot log into all the devices because of the session problems, right? So let's say you are running your test parallelly on all 8 devices, let's say, and with the same username password, if you log in, it will not work. You need an intelligent way to identify, hey, I am process number 1, and that's why I should use credential number 1. I am process number 2, I should use credential number 2. And this is how, using this environment variable, the process will know which process am I. So you can say, if environment test process number equal to 1, use this credential. If it is 5, use this credential. So you can basically support different action in different devices. So all good. We are all so happy. We solved 2 problems. One is our build time reduced by 70%, and we can run our tests on all various devices. We solve the problem of device fragmentation for free. Okay, but there's a alert, and that's basically we all love UI automation so much. As I said, within a span of 2-3 months, we doubled our test cases. And how long will this game go on? With the next 2-3 months, it will again get developed, and we will end up having thousands of UI tests. So we'll beat the hell out of our machine with multiple UIs. So we had to choose one. Lots of automation tests for good coverage or faster automation, and we chose both. We chose both. And our solution was distribution, parallelization. Right? Is there a better way to do it? Yeah. Let's go back to the basics. So this is a test pyramid, and I hope everyone knows about it. The test pyramid is it tells us what to test at what layer and how much to test. Okay. So as you see on the top of the pyramid, we have automated GUI test. That's where we are doing our distribution. That's where we are writing all of our tests, right? And basically, these are the tests which takes a lot of time, and these are the tests which are flaky. These are the tests which takes maintenance, cost. They are very costly, and they are very time consuming. So if you go from top to bottom, at the bottom we have unit tests. Unit tests are really fast, and they are very fast, and they take low maintenance. They are not very costly. So actually, you cannot move everything from UI test to unit test, but there are cases we automate some very trivial things. I should see when I log in, I go this flow, 15 minutes of flow, I go somewhere, I click on a button, it should give me error message. And we test this in the UI test. Does it really make sense there? We should keep end-to-end journeys at the UI layer, and all the trivial test case, we should try pushing down to the bottom of the test plan. We should ask our developers to write a unit test instead of rewriting a UI test for very trivial things. And this will automatically reduce the time. So before writing a UI test, next thing, let's see if it really makes any sense at this layer, or is there a better way? Like, can we ask our developers to write a UI test? Yeah, so this is a GitHub repository. This is GitHub repository of Untitled Calabash. You can go have a look at the code base, and if you find any bugs after using it, raise it there. I'll fix it. Also, you can, if you have any feature request or if you have any pull request to send, please do so. You can download it from the details. These are some good references I use. The top one being parallel test. This is a really good tool. If you are already using Selenium, this is the thing you should be using. I'm sure you there are lots of those.
You mentioned that you are able to do that scenario. Is it possible to do the devices
As in,
with the simulators? Because in the concurrent example, you have one iOS machine, one Android machine. So all the test cases will run on both machines.
okay, so I think I did not get your question, but if you are asking, as in, can you group the simulators and then divide between the simulators? Is that what you are asking? No, right now, no. But it's a good feature. I think you can send a pull request on that.
There may be a scenario where I have 6 iOS simulators and 3 KitKat simulators.
Okay.
So if I use the concurrent feature, my test cases will run all the simulators, but not the.
So the thing which I actually forgot to mention, this is supported only for Android. So iOS is not yet supported. I'm still working out on how can we do it distribution, because there is some limitation with iOS in getting the handle of the individual simulators when they are parallel simulators, iOS simulators. So this is only for Android.
Even in Android, there might be different.
Yeah, so you can run all the tests on all the devices. But if your question is, I have 3 KitKat devices and 3 let's say lollipop devices. I want to distribute all tests in equal here and all tests equal this side also, right? Yeah. So this is not yet developed, but it's something which can be developed. I think it's a good feature. I'll go on.
My question is, I know we parallelize but what about devices that's
Yes. So basically, there's no difference between emulator and devices. All you need to do is get a USB hub and connect as many. And you can actually do the combination of both. You can have 2 emulators and 5 devices. It will distribute across whatever is available.
sorry, one question. You talked about parallelizing tests, but what about tests that can be parallelized?
Yeah, that's a good point actually. So there are some cases wherein some tests cannot be parallelized because of dependency on some third system, right? Some tests actually need need a third system also to be present when that third system cannot be utilized by all tests. So that is not supported right now with this tool. But in our case also this was a problem. What we did was we had almost 100 tests which I covered. Out of this we could run almost around 85 tests and 15 could not be parallelized. So we actually parallelized the 70 odd tests and remaining we ran in series. There is one thing which I still need to add into it. Using the same executor parallel Calabash, you can pass a switch hyphen and hyphen executing series. It will the first connected device. So that's something which I'm still working on.
As like it's better to run the same test on different emulators versus actually, parallelizing the different tests on different devices. So I hope you have to feature when you are running two different devices. Rather than still take it on the same emulator, and those emulators will be different because one could be a lollipop or so I think still it's doable, right? Because nothing to do with that. All you need is an entity name, right? So you can spawn the different process altogether for that particular and for that particular product. And then you can
Yeah, it's already done.
exactly. So I don't see. So I don't understand the process that you asked different.
Okay, so his question was, let's say you have, so what can be done using parallel Calabash is you have a lollipop emulator, you have let's say one lollipop emulator and one KitKat emulator, and you have 10 tests, you can run all 10 tests on all devices. His question was, let's say you have 3 lollipop emulators and 3 KitKat emulators, and you actually want to distribute all tests on 3 lollipop and again want to distribute all 3 tests on this KitKat, so that you reduce the build time also for testing one specific platform and you achieve the parallelization of cross-platform.
Okay, so you want to have the same emulator, different same flavor, and then you want to actually run.
Yeah, a group of emulators all having specific platform. So a group of 3 emulators having KitKat, another group of emulators having a Lollipop. You distribute all the tests here, you distribute all the tests here. So you tested all tests on Lollipop also, you tested everything on the KitKat also, but by using the parallelized internal distribution. So that was his question. It's not yet done.
Yeah, assuming the screenshot,
Yeah, yeah,
you don't have to worry
yeah.
about it.
Yeah, so these things are basically delegated to Calabash. So they are,
And you can leave any data, any product.
yes, you can give any. So Calabash by will itself create the instrumentation backend, whatever you use.
So you need to have that same instrumentation in order to run that.
You don't need to have it. So basically, all the process will delegate it to Calabash, and Calabash will itself create and install the APK. So if you see, when I ran my test here, so I had connected 6 devices, right? But when you see, it actually installed how many? 12, right? So one is actually the actual APK, another is the instrumentation.
Why did you not actually
Because it automatically it resigns the application and creates the test server. So it's actually something which is by default available in Calabash.
So that it can execute those user actions what you have hired.
I'm just worried about the two different applications.
No. So one is your original APK, and to drive your original APK, Calabash creates one more APK, which is also installed along with it.
Calabash also monitors how much CPU usage is currently doing.
Calabash does not, but you can actually do it by using
Sometimes if
APK.
you are running, let's say it's 15 minutes is what you're time, because of the number of tests are added, those are running for let's say for longer time, and your CPU usage is almost 90% plus. Then it might slow down the other tests because there is no CPU or resource to utilize it. So does that monitor that point as well?
Okay, this you are talking about Calabash or this?
I'm talking about the time. So when I'm executing it parallelly, does it also monitor like CPU usage is 90% and I need to slow down the execution for the other devices so that it will be like smart resource
No,
utilization?
right now, no.
When we have seen when we are executing the test case and if your CPU usage is quite high, then your test will rapidly either fail or it might crash your
Right.
whole execution.
Right. So right now, what we in our project we are like 8 simulators, and all these processes, parallel processes, are very tiny Ruby processes. They do not consume much memory. So if I show you the memory consumed by one process, it's like 50 MB. So right now I have like 8 GB of RAM. So the memory is not a problem, and the CPU usage also, if you see, they are not these processes are not very high CPU. What I show you was in the
Spike was quite high.
spike. In the spike, you see this red dots and green dots. So these green dots are something which is user processors, and red dot are the OS specific processes. So what the spike which we saw was the user specific processes. Obviously, if you have like thousands of processes running, it will definitely put a load on the CPU. So right now that check is not there, but if you are going to connect like up to say 20 processes, I don't think it's going to be a load issue. But yeah, we can add this. So the more memory actually was by in that memory spike, half of the memory was actually being used by these processors itself, this Genymotion processor itself. Because Genymotion is basically one virtual machine in itself. So if I connect devices, basically this machine does not have load to simulate the Genymotions. So the spike was majorly because of 6 simulators being doing some actions.
One question, our application which we're working on, we have to test it online mode as well as in offline mode. So, how can we manage that thing? I didn't find a good solution for it. So, we normally test it offline mode manually, but we couldn't automate it.
Probably I did not get your question right, but if you are
The application needs to be run exactly similar way the way it works online, or if you are using Telegram or there's no network issue. So how to face those kind of scenarios using often.
okay, so you want to turn airport mode on and then test your application. Basically, it is doable. You can use the UI automator framework along with. So there is a tool called Honeydew, which is a wrapper over the UI automation, UI automator of the in Java, and you can actually infuse that driver also in your test, and you can do these things. We can discuss about it later on.
I think we are done.
Cool. So if you guys have any other questions, you can catch up with me offline. I'll be here till the evening. Thanks for attending.
So it was a brilliant session, I guess. At least for me. This is a small token of appreciation. Thank you.